much of a cross section. No pipes, no trees, no lines coming down, no levels, just that, and then the next one, then the next one, then the next one. Just so you can measure the areas, right? I'll give you probably somewhere around about 1 mark for doing that. That's the easiest mark I'm giving away, apart from those people who've got half a mark bonus. Then I'll give you half a mark for putting in the spreadsheet, which also isn't too difficult because you've got to put the distances in that you've nominated and the areas. And then I will give you something, I don't think that adds up to 3 yet, so you probably get another mark for putting it in the spreadsheet and putting that into model space, the drawing. You don't even have to do a viewport, just has to be in model space. And then we also, at some point today, are going to talk about the compaction factor. And yep, my friend the geologist at the back of the office is going to come up and he does it again. He controls your job. Every soil, every bit of sand, every bit of dirt, every bit of rock has got a compaction factor. Obviously rock would be very different to sand or clay. And that compaction factor is what I'm going to get you to, I'm going to give you a compaction factor, and you've got to apply that to your volumes. And it's not quite as easy as you think. If I was to summarise it, little Johnny, he's at home being looked after by his mum, but his mum's got about 3 other kids, so she's not really watching what he's doing. He grabs his dad's spade. He's seen his dad do it before, so he starts digging a big hole on the lawn in the backyard, on the father's beautifully groomed lawn that he practices his golf putting on. And the mother looks out the window, absolutely horrified. She goes running out there and says to him, you know, boy, this is something that often got said to me. I remember, you wait till your dad gets home, you're going to get a hiding. Little Johnny went, nah, he's quite confident. I'm going to fill it all back in again, and jump up and down on it, squash it. He says, Dad will never know. So he does that, he fills it back up again, jumps up and down on it, very proud of himself, and he turns around and there's a great big heap of soil still left. That's what the compaction factor is. Same with the ice cream that you get served in the shop. It's always bigger than the scoop, the bit of scoop that they've taken out because there's air inside it. And it hasn't been properly compacted, right? I got the sack from doing that. I used to work in a dairy and I was making ice creams and I was trying to get the air out of it and it kept on breaking the cone. So the compaction factor, we'll talk about that as well. I think some of you are starting to understand my analogy between little Johnny and on site. So you always got to allow, in Auckland, approximately 5%. Your soil or your clays in Auckland have a factor of 30% and 25%. Which has a balance of about 5% left over. So that's what little Johnny would have had. Yep, no problem. It's alright. And the other thing that we'll talk about today also, there's a couple of other things. As part of this course, I'm supposed to give you some notes on subdivisions. They do appear on other courses that you're going to be doing. I think you're tested on too much as it is on this course, so I don't tend to test or ask you to do anything as far as subdivisions go in terms of your notes or in terms of the drawings. But bear in mind, in Auckland, there are different zonings for subdivisions. So you can't like put 25 houses in the middle of an industrial zone, for example, and the other way around. You can't suddenly build a business, industrial business, in the middle of, you know, Henderson housing lot sort of thing. So those things are important, and they do come into play. And also some of that reflects on trees. So in certain zones in Auckland, you can't chop trees down at all if they're natives. In other zones, you can apply to chop them down if they're under 6 metres. So there's different rules. Waitakere is pretty strict, mostly bush out that way. So they don't really want you carving into it too much at all. Whereas there's very little bush left in downtown Auckland. And, you know, so if you've got there is something like 50 trees around Auckland downtown that have been identified as exotic. Exotic can be maple, which is an English tree, for goodness sake. And so those exotic ones have got special protection on them, but most trees you can in central downtown Auckland, you've got a pretty good chance that you can chop them down if you apply for a resource consent, yeah, even the native ones. So, and it changes from council to council. So all I wanted you to be aware of is I've got notes in there on that. You will come across a couple more subjects at your NT that you'll need those notes for. As a lead-in, I won't be testing on it, and I won't be making you doing anything on it in the assignment. You can use parts of it in your assignment if you wish. And lastly, we'll just talk about something that's quite important, and that's when you're planning a job with earthworks volumes, and you have got cut and fill on the job as you go along the road. But you'll often see on large road complexes there'll be large piles of gravel or whatever dumped, ready to be used, or cut, ready to be used somewhere else. That's planning a job so that it all runs smoothly. What you don't want to be doing is taking a whole lot of cut away and getting rid of it, and a bit further down the job you need that cut. So you're going to have to bring engineered fill in, which costs 2 or 3 times as more than if you kept the same cut. The other thing is, well, we pretend not to be a green nation, but we are pretty much a green nation when you look at other ones. And the minute you're bringing fill in from outside, that's where you get problems. A lot of contractors try to shortcut things. They'll have a mate with a wink, and there's a bit of extra fill over so and so. There's a bit of dirt in it, but the building inspector won't notice, and we'll bring it in and we'll hammer it down, and it'll be fine, you know. Wink, wink, nudge, nudge, and sort of 3 years later the house starts slumping a little bit. Nobody takes responsibility. So what I'm saying is that not just that, there could be toxins in it, there could be other things that could destroy the environment. So here at Unitec there's quite a few sensitive sites around here. They don't want you bringing in anything else than clean fill, right? But they don't inspect what you're taking out of the ground and you're reusing. So if you're taking clay out and you're reusing it over here, that's perfectly fine. So, but the minute you bring clay in from somewhere else, oh no, we need to test this, we need to test that, you know, sorry, you can't use it, blah, blah, blah. So, therefore, the designer's job is to try to balance that so everybody's happy. If you've got very similar amount of cuts and fill, and you're bringing not much on site, you've done well. You've saved quite a lot of money. And unfortunately, the amount of jobs that I've balanced very close to dead perfect. I've been very proud of it, given it to the big bosses to sign off, and the geologist has woken up at the back of the room and he's gone, actually I don't like the slope. Let's change that from 1 to 2 to 1 to 3, which means more fill, or less fill, or more cut, or whatever. I don't like the compaction factor. Let's make it 6. That means you've got more hanging around that you don't need. So he or she, although I've never come across a she, she'd be quite hairy faced probably, but anyway, he has been the bane of a designer's life, and I sometimes wonder where they drag some of the numbers from, but they do tend to cause a lot of trouble at the last minute. Because you imagine I've got a target by Friday and I've got my drawings to my boss on a Thursday ready to go out the door, and he's gone and changed the whole world around. So yeah, and my team are all just getting ready to go for beers on a Friday afternoon, and you tell them no, there's no drinking no beers this afternoon, we're back to the drawing board and we've got to get these changes done. So when we have done the volumes, they will go towards the assignment. Next week there's no lecture in here, so you can all have a lie-in. You can do some study towards your test. The test is going to be online. At this stage, I'm going to be doing it from my office. The revision is going to be online. The test will be as well. I think I've already said that. Yeah. So the revision class will be online. You have the option of going to 112 1100. Even though I won't be there, I'll get the past student to go there. So you can watch it here and still do your assignment, or you can stay home. I will mark those that are present on the Zoom as present for the lab. Zoom will be recorded, so after about an hour or so that'll drop back from the cloud and you'll be able to see the revision recorded, just in case there was something you didn't understand. You can go back and revise it if English is your second language and I'm talking too damn quickly, where you can just slow me up and listen to it or watch it. Okay. I do that every time. I think it's slightly better for the students. I do have students that record me, but you know, sometimes I'm bouncing around different parts and they don't see something, or they're not quick enough, or they're falling asleep and the camera's filming that side of the board and what have you. So it is kind of a bit easier if it's done like that. The test is only worth 10% for those that are repeating the course, and maybe 2 semesters ago it was worth 20%. It's only worth 10% now. That don't know me, that's an NZCE thing, a VE. They're trying to bring it a little bit more in line with the degree, but I'm trying to push back. I want this to be more in line, the other way around, the degree to be more in line with this one. The degree has an element of pain in the butt about it. They have to do presentations and reports as well as drawings, so I think you're better off sticking with the one you're doing now. Then we'll get a break and then we'll start into the structural side of it. Okay? So the notes this week I'm going to be going through fairly quickly. There's quite a bit of them, but as I said, the sections that are important, I will dwell on them a bit more, and you can read them, the rest of it, in your own time. Excellent.
为什么是没都没有9.25，对，不知道怎么来，应该是给的。
So, with your assignments, the sort of thing that a lot of you may have to improve on for your second one is to make sure that you've labelled your title block, put on a layer called title block, not a layer called 0. Your logo should go in a title block called logo, a layer called logo, and your viewport should be on a layer called viewport. You never viewport 1, viewport 2 if you want to, you're on a layer called viewport. Your tab should be renamed existing site plan, nothing else, because that's what it was asked for. And so obviously the other one will be long section, so the new ones will be section A and section B and proposed plan. Right? The text height should just about all be 0.35. A number of students varied that. Some were doing 0.5, some were doing 0.25. Some were actually doing 3.5 text, which was what was asked for, but in layout space. In other words, you had to do the mathematics, and 3.5 text was huge on the drawing. The other issues that I'm picking up so far is that the viewport is cutting off a lot of people's text and arrows. So if you're not sure what I mean by that, your viewport comes along like that, and you have your outlet structure beautifully drawn over here, and the pipe, away goes the pipe with the centre line on it, and that's showing a lot of promise. But unfortunately there's an arrow which comes in here, which off to the side of the viewport is outlet structure. And over here there's another arrow there going, to something else. Another arrow going to a pipe. But all the text and half the arrows are off the viewport. So the only thing I can see when I open the drawing is that. And if it was just one, I'd be, okay, that's fine, it's just one person that may need to come back next semester, but unfortunately it's quite a few. So all I'm saying is make sure you get that right next time. I can't count any of that text as being part of your drawing. So where you may have labelled things and put levels all over the place, which is good, and I expect that on the proposed plan, somewhere along the line there you've chopped it all off, which is not good. It's a bit like doing an assignment, and you just get the scissors out and chopping half the assignment off and passing it in. See, the problem is that you'll be asked to make a PDF out of that and send it off to the client. And the PDF ain't going to have the text on it. Because a lot of clients don't have an $8,000 copy of AutoCAD to open up your drawing on. Another common mistake was your labels for your contours were the wrong size, should be 0.25. That you will have to fix up for assignment before you copy that as your drawing for assignment 2. The trees are pretty good. Most people would put some time and effort into that, but a lot of people, for example, the survey traverse, which goes from peg to peg, and they've chosen a very small line type like that, right? I don't know what it was called, but it was a very small line type they chose, so they've done well. They've chosen the right line type, but in layout space they hadn't set their LT scale right, and so that just came out as a line You had to actually zoom in before we started seeing them. I'm not looking at anyone in particular because I still aren't very familiar with the names. By the end of the semester, I've pretty much got figured yous all out as to who's handing what in. So the line type, choosing a line type is one thing, choosing the line type scale is another. If you're having really bad problems because that's changing that, then you can just change that LT scale on that particular one. But I would suggest never use ACAD line types. There's a whole lot of line types that start with ACAD. If you use those, you're going to end up with issues when it comes to line type scale. So use, I'm pretty sure Ingrid's told you this as well, just use logical ones like dashed, hidden, pretty simple line types will get you through on this course. And a number of students presented their work in model space. That's a no-no as well, because I'm the client, I want to open it up in layout, zoom to the max, ready to print to PDF or whatever. If I've got CAD, I don't want to be going, where the heck am I? Oh, I'm in layout space. Oh, okay. I'm in model space. So which one am I after now? What tab down the bottom should I be clicking on? And unfortunately, sometimes when I clicked on the tabs, you were inside the viewport, which is a really dangerous thing to do because if the client zooms in and out, they lose the scale if it's not locked. Right. So there's a bit of it's not really a grumble, it's just trying to help you. And because you won't get a lot of time from the marking. Markings, I have till 5 o'clock on the day you hand in to get your marks back to you, which is 3 weeks. And because I normally struggle to do that, so you're only going to probably get a few days. I'm just trying to give a wee bit of a heads up of things that you can do before that particular time. Okay. For those that are got the laptop here, I'll make this available. Assignment to Dropbox should be open now if you want to use that to save your storage. Remember, you can drop in there as many times as you like. So we up to week 4, is that right? Sorry, 5. Okay, so at the end of week 4, I don't know if I put these on last time, but we have some notes on subdivision, zoning, and the developer, professional developers, consenting authorities, and applications for consent, and the type of what a concept plan looks like if you putting in 4 could see. Okay, here's my favourite drawing here. I'll keep referring back to this. This is the yellow bit is a road, and the bit on the right hand side at the top is where we're cutting through, and the bit on the bottom underneath is basically our fill. It's a bit like this. Cut, fill. And you can see the grey bits are the volumes underneath or above. So the amount of fill that's needed or the cut that's needed. The numbers there are how far along the road we've travelled in each case to get to those particular volumes. It's also quite good that it shows exactly the point at which the fill turns to cut, where it's balanced. And it leads into this mathematical equation here, which is the average of A1 plus A2 over 2, so divided by 2, times L, which is the length. So the first one would be the average of that and that times that distance there, which will be 3. Then you would have the average of that one and that one times that distance there, which would be 4. Right? And what the spreadsheet does when it's put into that further down, when I introduce that, is what it tends to do is it then takes into account these funny prismoidal shapes on the outside, and it realises that when there's a big area, there's quite a big factor that could go wrong, so it's got more of an allowance, whereas if it's 2 small areas, it's a very small allowance for the prismoidal factor. So there's a lot of assumptions with that method. The assumptions are that the earthworks looks fairly much like a 4-sided object, and it doesn't always. Earthworks can be sometimes a sort of 5 or 6-sided object to work out. And the assumption the road is flat. What isn't assumed is where on that job would you start to get the best result in terms of if you were progressing the job and you had to utilise as best as possible the cut and fill. Would you start at 0 end, or would you start at the 25 end and work back the other way? Yeah, you'd start at the 25 because you'd be accumulating cut, and as you push forward you can push that into the area of fill, and you'd only have to go away at the end and get a little bit of fill to finish the job. And that's kind of what I was talking about before. Quite a lot of planning goes into these things. You can imagine a motorway, 30 kilometres of motorway. They're always looking for extra cut that they can use further down the job or whatever. So there are more complicated ways of doing it too, like Simpson's rule, which I think you've got to have an uneven amount of jobs, of cuts, to use that. But the main one we're going to be talking about is the prismoidal correction one. And instead of me giving you the formula for that, I'm going to give you a spreadsheet for that. So if you've got a distance and you've got an area you can put them into the formula, and it'll pop out a cubic metre. To give you a bit of an idea, this method here that we were talking about, A1 plus A2 divided by 2, just using that method there on this example gave us 905 cubic metres, whereas the prismoidal method, which was a lot more accurate, gave us 9275. So that's a difference of about 225 cubic metres. Now, for those that don't have any conception of what that is, 6 cubic metres is a truck, your average truckload. So there's quite a few truckloads there difference because of the two methods that they chose to do their volumes. And that's why that guy was ringing me up for the spreadsheet. He wanted it as accurate as possible. Interesting. We've talked about the compaction and the bulking factor. So every soil, every clay, everything in the ground has got a compaction factor and it's got a bulking factor. The bulking is pretty much when you put it on the truck. You might have a hole that's just 5 cubic metres, you dig it out, you put it on the truck and it fills the truck up 6 cubic metres. And that means it's been bulking. Compaction is little Johnny jumping up and down trying to compact it back in the ground. And so in that particular case, a 30%, 25%, you end up with a 5% bulking difference, which is exactly what I was talking about. Ways to balance the quantities. Well, these are different ways that I've tried over the years of getting around the geotechnical engineer or geologist at the back of the office. It hasn't always worked because they also, remember, control the batter slopes, which is a bit of a pain. Mass curve diagrams. Now these mass curve diagrams, if you go back to up here, pretty much they show what the earthworks would do if you started from that end or you started from that end. And they have obviously a point at which it balances, and then you need more cut or more fill after that. So further down, or have I done it on a different page? No, I've done it on a different page. Scroll left. So further down on week 5, 3, 4, 5, mass curve diagram. I've done this exercise before during the labs, but I'll put some square metres beside these distances, and this is what it looks like on the mass curve diagram. So starting from the 0 end, which is not what you said start from the other end, and you're correct. You can see that all you're doing is you're getting more and more fill. Then you get into cut, but you never really end up recovering from that. So if you go from that end, you're continuously needing fill, which is not a good way to run the job. Whereas from this end, going from the 25 end, like you said, you start off gaining cut, and then you start using it at about there, and then there's a point around about 11 or 9 where it balances, and then you need to go down and buy yourself some clean fill. And that is a very basic, but a thing called a mass curve diagram. So as managers, if you go on to manage sites, a mass curve diagram is really important for seeing where you're at with the job. Are you keeping up with what they want? Or are you slipping behind? And are we doing it the right way, or are we doing it the wrong way? Remember, there's the job there. So that tells you how to plot the mass curve diagram. I really should make that other one available as well. So that you can have a look at that. In class, in the lab, we're going to do an exercise with the cosmoidal correction factor and that spreadsheet that I'm going to give you. Proposed plans. This is one from a previous year. You can see that the student has got butterfly wings on there, and they've offset a small amount first up, and then was 2, 2, 2, 2, 2. What I don't like about this, the pegs were left on. You were told to take the pegs off. They've put their contours, they've put an M on their contours, like 19 metres, 18 metres. I do like these batter slope symbols here. Don't forget to put them on your main drawing. And of course they go from the top of there as well. They shouldn't have done this dashed line here showing the centre line of the where A and B cut through. You remember from technical literacy, you just do a short line down to about here and erase those ones down to here. Just a short line, and that's about the right proportions there for a flag. I do ask for water flow arrows. Now, water flow arrows should be parallel to the, not parallel, perpendicular to the contour lines. And what they basically are doing is they're showing you which way the water would flow in a rain event. And they work very well if you start putting them on your drawing. There's probably too many on this drawing, and at least half that, but nevertheless it's not wrong. So how many is a good number? Probably about 10 to 15 on the drawing, and make them different to your normal arrows. What that reminds me of very much is I went to Eden Park to watch an All Black game once in the 90s, and I couldn't believe it. This busload of people from Hamilton arrived. No disrespect if you come from Hamilton, but they were pretty drunk and they were picking the fights on everyone. And this joker got up and for no reason at all just hit someone in front of him and sat down again. And he just put his head down with this. No one's going to see who did it, right? The whole crowd pointed at him. Unbelievable. The whole of the well, it was in those days it was an uncovered deck, and this just sea of fingers pointing at the one person coming in. Security guard, he's down here like this. Security guards took like under a minute, and there's these big chaps standing over him going, "Come with me." And that's what water flow arrow is supposed to do in a drawing, but not like Eden Park with thousands and thousands of them, just a few of them to show what direction the water's going. Council take it quite seriously because they don't want you to do a job like this and have the water flow coming off it going into somebody's garage or worse still going into the house. All right? So technically, if you supplied this plan and they approved it, then your responsibilities are fine from then on, right? Because council's approved it. I would prefer you did this stuff down the side of the page. I don't like the scale factor that the person's used on their wetlands. They could have done it a little bit closer together for the graph. The dashes are okay. You don't need a locality plan on your proposed plan. See, basically, those people coming to site are going to use your existing site plan, locality plan. Yeah, I mean, a truckie isn't that dumb. They do know after they've been to site once where to go the next day, right? So the proposed plan doesn't normally come out for quite a while. So you only need to put it on one. You can. The other reason is you don't really want double information. You're just as likely to move something accidentally or whatever, and the truck ends up in the wrong place. So you don't. You need the notes. You don't need the survey information. You don't need the locality plan. I do like what they've done here. You'll note that underneath the butterfly wings and the deck, and the platform, there's no contours. Technically the contours come in, they go around the earthworks and come out the other side. So technically you should have none in the middle. Any questions on that?
What's the dimension for the water flow?
Flowing arrow.
Well, it's approximately the same as your other arrows, but I'll just zoom in on it and see if I can get a better take on it. Yeah, you can right click on the arrow and do another head on it, a different type of head. If not, you could explode it and play with, stretch the arrow head. I would prefer if that was flat right across there, and then it would be more of that shape rather than that shape, which is your normal arrow head. Just a bit different. I've seen them all sorts. I've seen can't see anything at the moment because I've lost my pen. There it is. Okay. So you can have that one sort of a bit of a swanky one. Looks like a English moustache. Well, sort of does. Like you see, mini-series gentlemen. They're a bit like that. You could do that. I'm not really going to mark you on your arrow, I just don't want it the same as a normal arrow. You can tell that you can put that on the legend as a flow arrow. They work really, really well on catchment areas when you've got to decide say there's a mountain and the water is running that way or it's running that way. If it runs that way, it goes into that catchment area. And if it goes that way down the mountain, it runs into that catchment area. Sometimes it's a little bit tricky to tell where the top of the mountain is or where the ridge is and other bits. And that the water flow just makes it really obvious where the water is going. I had to do that for days and days and days on Fiji job. Job in the islands, and I didn't go to site, unfortunately. I could have sat in the resort for days and days, but it was after one of the cyclones hit, and they wanted the water flow arrows everywhere so they could see in a bad storm the places that they shouldn't go to, and B, that might need some extra remedial work. It's quite an interesting, when the cyclones hit Samoa, because there's the American Samoa, there's a lot of extra money got thrown at cyclone relief from America. And of course New Zealand being the closest company, all our engineering companies bid for work over there. They all did quite nicely out of it. They did good jobs, they fixed the bridges and everything. One of the students from Unitec came up with an idea for the piles on a bridge being made of, if you look through the cross section, being made of concrete that looked like that. And it's nothing to do with the Baltimore Bridge at the moment, which has got whacked and what have you. The reason was that by pointing that at the incoming water, the water flowed through it, but didn't kind of pick them up and wash them away. Which meant that when the water resided, because a lot of these rivers, creeks over there are just little dribbles until the cyclones hit. But it meant when it resided, it was very easy. The lid on top, the bit that people drove over, the boards, they were gone. But it was very easy to just put the boards back on again, and they had an instant bridge ready to drive on top of. So it was a Unitec student that came up with the concept and won an award for it sometime that year. Interesting. So your normal bridge design has got sort of something like that, and then something like this. And if you're looking in plan view, the boards go across, or the boards or the piles or whatever go across from one pole to the other. But this, when the water hits this, because it wasn't hollow, basically just knocked it out of the ground and took it with everything else. So there's a complete bridge rebuild they had straight away after. Especially that's when you need to get trucks on the road, because that's when your cyclone relief needs to be given to the families and what have you straight afterwards. So now he's waiting 3 months for a bridge to be built. So it was quite an interesting. So he did a display with. He was up against Auckland University and Canterbury University as well, and he won it over and above that, which was pretty impressive. And that's what they built it out of. Is it Latoko, the second island? And that's the capital city, isn't it?
Suva is the capital.
Yeah. It was the island that Latoko's on. Vitilu. Yeah, Vitilu. Yeah, that got whacked quite hard. It was back in the early 2000s, I think.
Okay.
Does that bring back memories? No?
Yes.
Yeah. Our company had a branch over there, so Simply Light Works was the name of the company. Sorry, killed the notes. I think that was just about all I wanted to talk about. I'm very aware that my friend will be here shortly. There's not a bone of scaredness about the whole thing. No.
We are.
You're paying money for the services, I'm not. Sorry, I'm getting way late here. You put me off. At least I haven't drawn much on the board this week. Right here.
Maybe we can say black link.
Move along then, here we are. Are there any questions at all about anything to do with the assignment or anything to do with the notes today? Nothing you can think of? Okay. The past students extending her time on Fridays, because there were some students that only had like a small corridor. So I'm pretty sure that that's, I'll check that before this afternoon. I think it's half an hour, 12, will she normally do 1:30 to 2:30?
Yeah. 1 to 2.
1 to 2?
Yeah.
I'm pretty sure it's 2. And you only got half an hour of it before she left, is that right? So did you ask her to extend it to 2:30?
We didn't ask her, we emailed you. And you
Okay.
said,
Yeah, alright, so we've got an extra half an hour of Ingrid for that, so it'll be a 1.5 hour session on Fridays. I'm sure you'll make lots of use of it the week beforehand, but I just thought I'd tell everyone now. I haven't announced it yet because they just approved today the room being available for the extra time. So for those that don't know what I'm talking about, the past student on a Friday with this subject had an hour, but some of the students were affected by another subject crossing over a little bit. She's going to, she's managed to get an extra half an hour for that, which is good. So we're going to do a small class exercise with the prismoidal cross sections in class this afternoon. The rest of the time you can have to do your assignment. I'll show you this again with the assignment. Remember, you will have to draw up one of these really nicely for me, but I'll show you what I'm expecting you to do to get the full marks for the volumes. And each student will be a little bit different than the next one, so you can check it against your friend, but don't expect it to be spot on exactly the same. There will be small differences in it. Okay? In terms of this week's notes, everything there talks about the mass curve diagram, which I gave that example of whether you start from one end to the other. I have got some questions in the test on that, and I've got some questions in the test on how to balance the quantities. So if you're going to put a mark beside any of that on the notes, I would definitely look back over those two sections. So there's a checklist that's already there also there for the proposed site plan, and there's some more explanation of some common uses, what spoil is, bulking is, borrow is, compaction factor, fill, etc. So that's what the Prism Watercross spreadsheet looks like, this one at the top that I'm going to give you. I'll go over that, as I said, in class, and we'll get a small example to do. These are tables. You won't need that table because this calculates the end area for you. That's how we used to do the tables in my time before spreadsheets were around. Thank goodness for spreadsheets. Well, that's it. Somehow I've finished just bang on time for the next class. That was lucky. So, yeah, no questions. We'll remember next week, no lecture.